For years, the electric vehicle industry has felt like a non-stop battle. Billions of dollars have poured into research, manufacturing, and innovation. Battery companies competed to deliver better performance. Charging networks expanded across the globe, and new EV startups seem to appear almost every few months, only for many of them to disappear just as quickly. At the center of this intense competition stood one company that everyone else was trying to catch. Rival automakers invested enormous amounts of money in an effort to close the gap with Tesla. Then Elon Musk revealed something that completely shifted the conversation. It wasn't a new vehicle, a software update, or a faster charging system. It was a new electric motor. As industry experts began to understand what this motor represented, the reaction was far from ordinary. Engineers and researchers who had spent decades studying electric drivetrains realized this wasn't just another improvement. It suggested something much bigger. Tesla wasn't simply staying ahead of the competition. It had moved so far forward that many believed it was now operating on an entirely different level. Some analysts have even described this moment as the beginning of the end of the EV race. Not because competitors have stopped trying, but because the final outcome may already be taking shape. For more than a decade, one sentence summed up the electric vehicle industry. Everyone was chasing Tesla. When electric vehicles transitioned from a futuristic idea to a commercial reality, a company with no history of building mass-market automobiles suddenly became the leader of a market the entire automotive world wanted to dominate. Tesla became the benchmark. It wasn't Ford, despite more than a century of manufacturing experience. It wasn't General Motors with its worldwide production network. It wasn't Toyota, a company famous for manufacturing efficiency, nor Volkswagen, whose presence spans nearly every major automotive market. It was Tesla that everyone watched. Traditional automakers believed Tesla's advantage wouldn't last forever. History had shown that first movers often lose their lead once larger competitors catch up. So the race truly began. Billions of dollars were invested in electric vehicle programs by companies that had barely considered EVs only a few years earlier. Manufacturers hired thousands of engineers, announced massive battery factories across North America, Europe, and Asia, and accelerated their transition plans. Governments also encouraged the shift through tax incentives, infrastructure investments, and manufacturing support designed to reduce dependence on gasoline-powered vehicles. At the same time, new startups entered the market almost every week, each claiming it had the technology that would finally outperform Tesla. Investors poured money into companies that hadn't even delivered a single production vehicle. Stock markets rewarded future promises almost as much as actual results. For a while, it seemed like any company with enough funding and the right vision could become the next industry leader. To be fair, the competition improved significantly. Legacy automakers released electric vehicles that were genuinely competitive. Driving range increased, battery technology advanced, and charging infrastructure became more reliable and widespread. Many industry analysts believed Tesla's dominant position was slowly becoming less secure as the market matured. For a moment, it looked like the gap between Tesla and its rivals was shrinking. Then Tesla made another move. It wasn't a flashy advertising campaign or another aggressive price reduction. Instead, the company introduced a new motor that immediately captured the attention of the engineering community. The response wasn't excitement. It was concern. Experts who studied the technology concluded that this wasn't simply an upgraded version of existing designs. It represented a completely different approach. According to many of them, competitors wouldn't be able to match Tesla's progress anytime soon. Some estimated it would take several years, while others suggested it could take close to a decade. The most significant realization was this. While every other automaker had been working tirelessly to catch Tesla, Tesla had quietly taken another major leap forward. What once looked like a close race suddenly appeared far less competitive. However, understanding where Tesla is heading also requires looking at where it faced challenges. The Cybertruck stands as one of the most talked-about vehicle launches in modern automotive history. When Elon Musk first introduced the vehicle, it instantly became one of the biggest topics in the industry. Its stainless steel exterior, bold, angular design, ambitious performance claims, and surprisingly competitive price generated enormous public interest. The truck looked unlike anything else on the road, and millions of people wanted to know more. Social media quickly amplified the excitement, while reservation numbers suggested demand would be exceptionally strong before production had even begun. But reality proved to be more complicated. Despite attracting tremendous attention, Cybertruck sales ultimately fell short of many analysts' expectations. The launch demonstrated an important lesson for the automotive industry. Generating headlines and online excitement is one thing, but convincing customers to make a purchase is something entirely different. Reports later suggested that a notable share of Cybertruck registrations during certain periods may not have come from everyday consumers at all. Instead, many were reportedly purchased by companies connected to Elon Musk, including SpaceX and XAI. Some analysts estimated that nearly 1 out of every 5 Cybertrucks registered during those quarters could have gone to Musk-affiliated organizations rather than independent buyers. When those internal purchases were excluded, Tesla's sales performance appeared even less impressive. The timing also worked against the Cybertruck. When the vehicle was first announced, Tesla had very few serious rivals in the electric pickup market. But by the time production reached meaningful levels, the landscape had changed dramatically. Nearly every major automaker had introduced its own electric vehicles, giving customers a much wider range of choices across different prices and styles. As competition increased, Tesla could no longer rely solely on its reputation to win buyers. Standing out in the market became much more difficult. The Cybertruck itself also proved to be one of Tesla's most polarizing vehicles. While many admired its futuristic appearance, others questioned its everyday practicality. Concerns about its price compared to traditional pickup trucks, along with reports of recalls and quality control issues, created additional obstacles. These challenges weakened the narrative Tesla had hoped would drive widespread adoption. Once consumer confidence begins to decline, rebuilding it can be a slow and difficult process. Rather than slowing its ambitions, Elon Musk shifted the company's focus even further toward artificial intelligence, robotics, and autonomous driving technologies. Tesla increasingly positioned itself as more than just a car manufacturer, aiming instead to become a technology company developing intelligent machines capable of operating with minimal or even no human involvement. In many ways, the Cybertruck became a symbol of the tension that has long surrounded Tesla, the gap between extraordinary expectations and real-world results. That gap has defined some of the company's most challenging moments. At the same time, history has shown that periods of skepticism have often been followed by some of Tesla's biggest breakthroughs. To understand why Tesla's latest motor has attracted so much attention, it's important to recognize one of the biggest limitations that electric vehicle engineers have faced for years. The obstacle wasn't a lack of creativity or ambition, it was physics. Designing an electric motor always involved compromise. Increasing performance meant generating more heat, adding extra weight, draining the battery more quickly, and requiring larger cooling systems that increased both complexity and cost. On the other hand, optimizing a motor for efficiency often reduced the exciting performance that many drivers expected from a premium electric vehicle. For years, the industry accepted these trade-offs as unavoidable. Tesla's engineers chose to see them differently. Instead of accepting the limitations, they searched for a way to overcome them. Their solution centered around what sounds like a surprisingly simple innovation: a carbon fiber-wrapped rotor. Inside every electric motor, the rotor is the spinning component that converts electrical energy into motion. As rotational speeds increase, enormous centrifugal forces build up, placing tremendous stress on the rotor. Traditional materials eventually reach their structural limits, preventing engineers from safely spinning the motor any faster. Carbon fiber changed those limits. Known for its exceptional strength while remaining extremely lightweight, carbon fiber has long been used in aerospace, motorsports, and other high-performance industries. By wrapping the rotor with carbon fiber, Tesla created a structure capable of withstanding forces that conventional designs simply could not handle. This allowed the motor to operate at speeds exceeding 20,000 revolutions per minute, a level typically associated with advanced industrial equipment rather than everyday passenger vehicles. But high rotational speed was only part of the achievement. The carbon fiber reinforcement also improved stability, minimized vibration, and enhanced magnetic efficiency, even under extreme operating conditions. As a result, less electrical energy was wasted as heat, allowing more of the battery's stored energy to be converted directly into forward motion. Together, these improvements largely removed the trade-off that had shaped electric motor design for years. Instead of sacrificing efficiency for performance, or performance for efficiency, Tesla moved closer to delivering both simultaneously. The Tesla Model S Plaid demonstrated what this technology could achieve in the real world. It accelerated from 0 to 60 miles per hour in less than 2 seconds, outperforming many purpose-built supercars that cost several times more. Yet it still offered the comfort, practicality, and driving range expected from a luxury sedan. For years, many engineers believed combining that level of performance with everyday usability simply wasn't possible. Tesla proved otherwise. Throughout automotive history, manufacturers have introduced concept cars, experimental technologies, and record-breaking prototypes that generated excitement but never became practical production vehicles. Building one extraordinary machine is impressive, but manufacturing millions of them at a competitive price while maintaining quality is an entirely different challenge. That is where many ambitious EV companies have struggled, and where Tesla has built one of its strongest competitive advantages. The automotive industry has repeatedly seen startups unveil revolutionary electric vehicle concepts, attract billions in investment, and then run into the harsh realities of large-scale manufacturing. Transforming an impressive prototype into a product that can be built consistently, efficiently, and profitably while meeting quality standards remains one of the most difficult achievements in modern industrial production. Tesla learned one of the automotive industry's toughest lessons early in its journey. The company endured years of manufacturing setbacks and production bottlenecks before finally mastering large-scale vehicle production. Those difficult experiences gave Tesla something that can't simply be bought or inherited: real-world manufacturing expertise. Today, that experience is shaping the company's next generation of drive units. Tesla is designing its future electric powertrains by integrating the motor, power electronics, and gearbox into a single, highly efficient system. From the beginning, these components are being engineered with large-scale manufacturing in mind, rather than treating production as an afterthought. One of Tesla's biggest goals is to reduce the manufacturing cost of an entire drive unit to around $1,000. That target caught the attention of the automotive industry because many competing systems delivering similar levels of performance reportedly cost anywhere from 3 to 5 times more. When those savings are multiplied across millions of vehicles, they don't just lower manufacturing costs, they transform pricing strategies, profit margins, and overall competitiveness. Tesla is also working to strengthen its supply chain by reducing dependence on materials and components that are difficult or expensive to source. One major focus is removing rare earth materials from future motor designs, helping reduce reliance on supply chains that are heavily concentrated in China. At the same time, Tesla is redesigning its power electronics to use less silicon carbide, a high-performance but costly material, while maintaining similar levels of efficiency. Each of these improvements supports the others. Lower production costs allow Tesla to offer more competitive vehicle prices. Lower prices attract more customers, increasing production volume. Higher production volumes improve manufacturing efficiency, which lowers costs even further. That creates a self-reinforcing cycle that becomes increasingly difficult for competitors to interrupt over time. The current competitive landscape highlights just how challenging this has become. Ford achieved meaningful success with vehicles like the Mustang Mach-E and the F-150 Lightning, proving there is strong demand for its electric models. However, despite growing sales, the company's EV division has reportedly continued to post significant financial losses. Lucid Motors has earned praise for building technologically impressive luxury electric vehicles, but it has also continued consuming large amounts of capital as it works toward long-term profitability. Meanwhile, industry giants such as General Motors and Volkswagen have faced their own obstacles, including software delays, changes to EV development plans, and ongoing discussions about how quickly they should expand their electric vehicle programs. Among Tesla's global competitors, BYD stands out as one of the strongest challengers. Its massive production scale and highly competitive manufacturing costs have made it especially successful in price-sensitive markets around the world. However, BYD and Tesla are pursuing different strategies. BYD has built much of its success around affordability and high-volume production. Tesla, on the other hand, is aiming for something more ambitious, creating some of the world's most advanced and desirable electric vehicles while continuously lowering the cost of building them. Combining cutting-edge technology with declining production costs is a competitive advantage that few companies have found an effective way to match. Many people still think of Tesla simply as a car manufacturer, but that perspective overlooks the company's greatest strength. Tesla has built an entire ecosystem of interconnected technologies that reinforce one another. Its competitive advantage doesn't come from a single product. It comes from the way all of its technologies work together. Looking at just one part of the business fails to capture the full picture. One of the biggest advantages begins with data. Every Tesla driving on public roads continuously collects information about road conditions, traffic patterns, weather, driver interactions, and countless unusual situations that challenge autonomous driving systems. That data is sent back to Tesla, allowing the company to improve its artificial intelligence using real-world driving experiences on an enormous scale. Since autonomous driving is fundamentally an AI challenge, the quality and quantity of real-world data become incredibly valuable. Over the years, Tesla has accumulated more driving data than almost any other organization in the world. The process creates another powerful cycle. More vehicles on the road generate more driving data. More data improves the AI. Better AI makes Tesla's vehicles more attractive to customers, leading to even more sales and an even larger fleet. As the cycle repeats, the company's advantage continues to grow, making it extremely difficult for competitors to catch up within any meaningful time frame. Tesla's strategy extends well beyond vehicles themselves. The company's 4680 battery cell reflects the same philosophy of improving efficiency while lowering costs. The new battery design aims to increase energy density, simplify manufacturing, reduce production expenses, and improve overall vehicle performance. Because batteries are typically the most expensive component of an electric vehicle, companies that rely heavily on outside suppliers are often limited by someone else's technology roadmap and production costs. Tesla has spent years bringing more of that process in-house, giving it greater control over battery development and manufacturing. The same approach applies to software, semiconductors, and vehicle electronics. When global chip shortages disrupted the automotive industry, many manufacturers struggled because they depended on specific semiconductor suppliers. Tesla adapted much more quickly by rewriting its software to work with alternative chip architectures, allowing production to continue with far less disruption. Traditional automakers often had limited options under those circumstances. Tesla's in-house engineering capabilities gave it far greater flexibility. Tesla's global manufacturing network adds another important advantage. Gigafactories in Fremont, Shanghai, Berlin, and Austin allow the company to manufacture vehicles close to major customer markets, reducing transportation costs and improving supply chain efficiency. As Tesla continues expanding with new facilities under development in Mexico and potential future operations in India, its global manufacturing footprint is expected to grow even stronger, creating additional opportunities to improve production efficiency while further reducing costs. Another major piece of Tesla's advantage is its supercharger network, something many people initially underestimated. In the early days, critics dismissed it as nothing more than a convenient charging feature. Over time, however, it became clear that it was much more than that. Tesla built one of the most dependable public charging networks available. While many competing charging providers struggled with unreliable stations, payment issues, and inconsistent maintenance, Tesla focused on creating a charging experience that drivers could trust. That reliability helped strengthen customer confidence in owning an electric vehicle. Eventually, the industry's response wasn't to create a better charging network, it was to adopt Tesla's. Both Ford and General Motors announced that their future electric vehicles would use Tesla's charging standard, allowing their customers to access the company's supercharger network. In an unexpected twist, some of Tesla's biggest competitors now depend on Tesla's charging infrastructure to improve the ownership experience for their own customers. At the same time, Tesla generates revenue whenever drivers of those competing vehicles use its charging stations. That's more than simple competition. It's a powerful example of ecosystem control. The farther you step back and look at Tesla as a whole, the less it resembles a traditional automaker. Instead, it begins to look like a technology company whose products extend far beyond cars. One example is Tesla's Dojo supercomputer. Dojo wasn't built to handle routine business operations. It was designed specifically to process the enormous amount of driving video and real-world data collected by Tesla's global fleet every day. Training artificial intelligence capable of making safe, autonomous driving decisions requires an extraordinary amount of computing power, far more than conventional systems can efficiently provide. Rather than relying entirely on cloud computing services from companies like Amazon, Google, or Microsoft, Tesla chose to develop its own high-performance computing platform. Although that decision required significant investment up front, it aligns with Tesla's long-term strategy. Control the technologies that matter most, reduce dependence on outside suppliers, and build internal capabilities that become more valuable over time. This approach creates a powerful cycle. Better vehicle technology attracts more customers. More vehicles on the road generate more real-world driving data. That data helps improve Tesla's artificial intelligence. Smarter AI enhances autonomous driving capabilities, making every Tesla more valuable to current and future owners. As vehicle value increases, Tesla can maintain healthier profit margins. Those profits are then reinvested into new hardware, advanced research, and future technologies, allowing the cycle to begin again. With each iteration, Tesla strengthens the advantages it already possesses. For competitors, this creates a unique challenge. Improving just one area isn't enough. A company may develop a superior battery, but it still has to overcome Tesla's enormous driving data advantage. Another manufacturer may build excellent software, yet still struggle to match Tesla's manufacturing efficiency and production costs. Even if a competitor narrows the cost gap, it still faces Tesla's established charging network, brand recognition, and loyal customer base. Each part of Tesla's ecosystem reinforces the others, making the overall business increasingly difficult to challenge. That's why Tesla's carbon fiber-wrapped motor is significant for more than its engineering achievements alone. It represents another step in a much larger pattern. Tesla doesn't simply introduce one breakthrough and spend years defending it. Instead, the company continues developing the next innovation while the rest of the industry is still trying to catch up with the previous one. The new motor joins a growing list of technologies that includes the 4680 battery cell, the Dojo AI training system, the supercharger network, and Tesla's massive advantage in autonomous driving data. Each innovation is impressive on its own, but together they create an interconnected ecosystem that becomes stronger and more difficult to compete with every product generation. There is little doubt that the electric vehicle revolution is underway. Around the world, the shift away from traditional gasoline-powered vehicles continues to gain momentum. What may be changing, however, is the industry's original expectation of how that future would look. Many believed the EV market would eventually consist of numerous strong competitors sharing the market with no single company dominating the field. Instead, a different possibility is beginning to emerge. Tesla increasingly resembles a technology platform with automobiles at its core, one that operates across energy, software, artificial intelligence, manufacturing, and data all at once. Its pace of innovation often moves faster than the traditional automotive industry can comfortably respond to. Whether Tesla ultimately fulfills that vision or eventually faces the same kind of disruption it once brought to the automotive industry remains an open question. What seems much harder to dispute is that Tesla is no longer the same company it was just 5 years ago. Its latest motor wasn't simply another product announcement. It was a statement about where the company believes the future is heading. So, what do you think? Can an electric motor that many believed wasn't possible redefine the future of the automotive industry? Can Tesla maintain its technological lead, or will another company eventually catch up? Share your thoughts in the comments below. And if you enjoyed this story, don't forget to like the video and subscribe for more content like this.